Capturing impressive deep sky astro images is easier than ever with Celestron's Rowe-Ackermann-Schmidt astrograph, the perfect companion to today's top DSLR or astronomical CCD cameras, the ultimate astro imaging tool. This telescope is optimized exclusively for wide-field imaging. Just attach your DSLR or CCD camera to the front of the telescope and you're ready to produce stunning astrophotos. This fast f2.2 system helps you create better-looking images in a fraction of the exposure time. A 70mm image circle accommodates even the largest CCD chips for pinpoint stars all the way to the edge of the sensor. High-quality, rare earth glass produces images free of false color. A brass focuser reduces image shift, while the dual-speed, feather-touch microfocus knob provides the most precise focusing. A 12-volt maglev fan decreases cooldown time and blocks dust. The astrograph includes camera adapters for easy attachment to popular CCD and DSLR cameras.
Like this, you'll have cables running out as well. So depending on how you want your diffraction. G'day, Dylan O'Donnell again, back for a video about the RASA, which I promised you. I should start by saying I don't know if it's pronounced RASA or RASA. It stands for Rowe-Ackermann-Schmidt astrograph, so I suspect the correct pronunciation would be RASA. But I'm Australian and it just feels natural to say RASA. It sounds a bit posh, doesn't it? Now, a bit of a disclaimer, I am on Team Celestron. I'm a huge RASA fan and just Celestron products generally. I use Celestron most of the time. I did get this at a pretty steep discount because it was a early model refurb, so I got it straight from the Torrance factory after it was refurbished. But still, it's an amazing telescope, and I'm saying that honestly. I will go through the critiques I have of it and things you should know before you get one, but hopefully this video will help, particularly if you are looking at getting one or you're just curious about what this new kind of telescope is all about. This is the 11-inch RASA. There is a 14-inch RASA mentioned in the white paper. Those aren't really available to the public just yet, but I do know that there are observatories using those. Whether they will be released to the public remains to be seen. If they are, it would be a terrific focal length, and it would be around the 780mm focal length, which is pretty good. For a wide field telescope, that's quite a tight target. Orion Nebula would be basically filling the entire frame and in excellent detail. And I worked that out using the Bintel calculator, which is actually something I developed. So if you're interested in working out all that sort of stuff and getting previews of your targets and focal lengths and that sort of thing, whether you use a camera or eyepiece, that is on their website. And really, a 14-inch f2 RASA would be a galaxy hunter. That kind of light collecting potential would be amazing. So what is it? It's a wide field telescope. Normally when you see a big telescope you think high magnification. But this is not a high magnification telescope. This does not zoom in really close to distant objects. It's not your ideal telescope for things like planets, for example. In fact, it's unworkable for planets. However, what it lacks in magnification, it makes up in just a pure photon collection. We're talking f2.2, which is amazingly fast. Now, if you're not familiar with how f-stops work, typically a Schmidt-Cassegrain telescope is f10, so it's quite slow. It's fine for bright things like planets, and it's high magnification, so it is good for planets. But f-stop is not linear. Something that you image at f10 doesn't take half as much exposure at f5. So something that you image at f2 takes something like 30 times less exposure than it would at f10. So it's a huge increment. Imaging at f2.2 is ridiculously fast. Stuff that was really faint, things like the Horsehead or the Rosette Nebula, suddenly are able to be imaged within 30 seconds even, and quite deep imaging, so you see a lot of nebulosity and a lot of detail. So what do you get? Let's have a look at the RASA itself When you buy a RASA, which is a very expensive telescope, they started retailing at $10,000 here, so it's not a small investment, it's a big investment in a telescope. What do you get? Basic, just this, just the OTA. So let's go through it. So you've probably seen this setup before with Hyperstar or Farstar. The imaging happens at the top end of the telescope, which is counterintuitive, right? The light's coming in here and you're putting a big obstruction up the front. But this is how the Schmidt astrograph works. The light comes in, it's bounced off the plate mirror at the back and then back up to this focal point right here where the camera is. Now, historically, the Schmidt camera or the Schmidt telescopes that were used in observatories, the focus point was back here in the telescope. So they actually put the camera inside the telescope, which, as you can imagine, is not easy to do and certainly not a good setup for a consumer. So this design corrected for all this to get the focus point right up here. Now we can put a camera at the front. Now, when Farstar was first released, cameras were still pretty big, so in a sense it was a bit ahead of its time. Now cameras are getting smaller and their footprints are getting as such where we can put them up the front here. But let's have a look at how this is set up. So there's my QHY9 that I've just taken off, and you'll see here I have one spacer just to get the correct focus point, and I have the filter draw system. Now this filter draw system is actually from the Hyperstar. So this is something that I found very useful when using Hyperstar, and it's still very useful with the RASA. If you have one of these or you are going to do narrowband imaging, I definitely recommend it. And of course this attaches onto the 2-inch thread for your cameras. They also provide another adapter, so you can put on a 125 adapter and screw on a smaller camera there if you want. By the way, this filter drawer is magnetic, so they just sort of clip in, which is fantastic. Now obviously when you have an obstruction at the front of the telescope like this, you'll have cables running out as well. So depending on how you want your diffraction spikes, and you can have slight diffraction spikes, you can position your cables running out at 90-degree angles like this, so you get the 4 pointed stars. But generally diffraction spikes are very minimal, which I like. I don't think it's great to have diffraction spikes all over your images. They look pretty cool for clusters and things though. You'll see at the back here we've got the typical lock screws and focus knob. Now the focus on this one, because it is that older early model refurb that I got, this isn't the focuser you would get. You would get a feather touch style focuser, but this is a stock 11-inch SET focuser. Now this thing in the middle here, that's a fan. You can see my RASA is getting bombarded with sun at the minute. This tube gets pretty hot, that's going to affect your focus. So this fan here extracts air and pulls it down to the ambient temperature a lot quicker. So let's try and give you this little dicky 12-volt battery pack for using AA batteries to plug in there. I've always wondered why Celestron puts in cheap or no power adapters at all. They make such great stuff. You've paid $10,000 for a telescope, you'd think they could throw in a bit of power for you. Just a regular power adapter would be great, or a cigarette lighter or something to actually be usable in the field. This is really quirky. So I'm just using a regular power adapter, 12 volt, 2 amps on this one, and that gets the fan going, and that actually works pretty well, I've found, at night. I had to close the dome because it's just so windy and sunny out there. I didn't want to get this too hot. So how does it actually perform? I have to say this thing has really upped the game in terms of my imaging. Now you may know that I've been a Hyperstar fan for a while, and I've used Hyperstar effectively for ages. There is another video on the Astro Imaging channel where I deep dive into Hyperstar technology, and this technology is essentially very similar. It's almost exactly the same. It's just that they've built Hyperstar essentially into one OTA, into one telescope, so that you don't have to use an extra adapter, you don't have to screw things on and off, you don't have to play with the flatness of the field and the collimation. You can collimate this, but it's really fiddly with some Allen screws. If you do have an authorized vendor who can look after that for you, I would trust it to them. I'm not game to get up there with an Allen key so close to the front of the telescope and risk scratching the glass or anything like that. I'm definitely not confident in my own abilities doing that. But thankfully, once it's collimated, it's actually solid. You really don't need to touch that. So don't muck around with that stuff if you can help it. Because you're putting everything at the front of the telescope, you are going to lose the ability to put on big things such as motorized filter wheels and focuses and things like that. So get used to doing things a little bit more manual, like using that filter draw system to swap out the filters. That said, you're imaging so quickly and you can knock over images so quickly, it's not that big of a deal. It's not like you're automating everything to the point where you need to leave it running overnight then come back the next day. You can swap filters, go have a cup of tea, come back and do the next filter. It's not that long. One thing I noticed immediately was it was a lot more difficult to focus than I realized. The critical focus zone is very, very small, and because the exposures that you take are pulling in the photons so quickly, you do see the halo of the plate at the back. So you will get this round fringe around your stars, and be aware of that as you're focusing, because I do think it trips up the HFR reading on your focus routine. So make sure your focus exposures are really, really low, and try and choose some really faint stars, because things blow out really quickly on this thing. It's great for nebulosity, but bright stars will be surrounded with a big halo, and that can be a problem for stars like Allentak in the Horsehead Nebula. They will have a big plate around them. The field of view on the 11-inch is 620 millimeters, thereabouts, which is actually pretty good for a lot of those big targets. I'll show you some example images. So if you're thinking about buying a scope like this, there are a couple of things to bear in mind. You cannot use this telescope for visual. There is nowhere for an eyepiece to go. And that's fine. This is designed for photographers. It has a flat field for photography. It's designed to push those photons straight onto a flat plane on the chip, on the camera chip, and have as true as possible stars right to the corners of the frame. Celestron lists this particular setup, which is the 11-inch RASA and the CGX mount, as their ideal imaging setup. And I have to agree, it's actually really, really forgiving. You can come away with a really deep exposure after only 2 hours imaging. For example, this is a 2-hour mosaic. So I've spent basically 30 minutes on each panel, and I've done that twice, once for hydrogen alpha run and another one for the colour run. So 2 hours to pull out an image like that is super, super fast, especially when you are pressed for time, you're at a dark sky site, or even an observatory like mine, and you just want to knock over something very quickly before it disappears out of view. You can have a full image done in one night, a fully spectacular image. So obviously the potential for aesthetic imaging is good. I have actually connected a ZWO camera to the front of it, and when you stick it into a bright target like Orion or something like that, you are essentially looking at a video. The potential for the RASA being used for video astronomy is excellent. As things get better with cameras, and as the pixels get smaller and more sensitive despite their size, and the quantum efficiency improves, this sort of telescope will just get better and better. In a sense, it's a little bit ahead of its time still. We need cameras that are smaller, have a smaller footprint, so they aren't blocking too much light at the front. And then a telescope like this in various different sizes will be a fantastic addition for any astrophotographer. The other use I really should discuss is the potential for sky surveys. We know that the 14-inch RASA is something that observatories would be really, really happy to use. when you're doing astrometry and you're looking for asteroids or near-Earth objects, comets, that sort of thing, you want to cover a wide chunk of the sky quickly, and you want to take exposures that are deep enough where you can identify faint objects, but preferably without those objects streaking. So if you're doing a long exposure on an asteroid, it's going to turn into a line. But if you can pick up rapid exposures and do large swathes of the sky, this is a perfect sky survey tool. I know that the hyperstars and the RASAs are already very popular with backyard comet hunters and people who work with a minor planetary centre to identify asteroids and things like that, and professional observatories who often don't have a lot of resources. A $10,000 telescope with this kind of potential isn't actually that expensive. That's actually a very good deal. The fact that it's in consumer hands at the minute, I think, is remarkable. I can actually show you a asteroid I discovered in one of my old RASA imageruns just the other day. And I used astrometry to figure out what that asteroid was, and you can see the asteroid is very clearly resolved and round. So that's a new I might do a video on that. That's a new field of astronomy I'd like to get into a bit more. One other thing I should talk about again is the obstruction at the front. You obviously want a small camera with a small footprint. But the other thing is, this is the 11-inch dew shield, and obviously it makes things very large. It's a very impressive looking telescope. I can tell you, it looks massive. But before I got an actual 11-inch dew shield, I fashioned one up myself using some felt, and I got to be honest, it was not a good idea. It doesn't hold its circular shape well enough, and if you do that, your stars become misshapen. I can put an example of that here. So that's about it. Hopefully I've gone over everything I meant to. For those who are interested, you really should download the white paper. It's on the Celestron website under the 11-inch RASA product page. It's a big document, but it goes through the history of the telescope as well as the actual specs, focal lengths. It's actually a page turner. It's a really good read, maybe for a nerd like you and me. So that's it. Thanks guys. I hope I covered everything. If I didn't, please leave a comment. And if you've got any other ideas for videos, please let me know. Alright, bye bye.